So say we know that the delta H of a reaction for the combustion of carbon to CO2 is negative 395.5 kilojoules per mole, and the enthalpy for the combustion of carbon monoxide to carbon dioxide is negative 283.0 kilojoules per mole. Here's the two reactions we're going to start with, right? Using these data, calculate the enthalpy for the combustion of carbon straight to carbon dioxide, or carbon monoxide, excuse me. Now, we know the delta H reaction for these two reactions right here. We don't know it for this one. We're going to use Hess's law to combine these two reactions in a way to produce this reaction exactly and give us the delta H that we need. The first thing that we should do is we know we want to start with carbon, right? And we know we want to end with carbon monoxide. Now the problem here is that carbon monoxide is on the reactant side. So what we're going to have to do is run the reverse of reaction 2 to get the amount we want. So I'm going to rewrite some of these equations right down here in the fashion I want. I want carbon plus diatomic oxygen producing carbon dioxide in its gaseous form. And that's a delta H equals negative 393.5 kilojoules for every mole of reaction. And in this case, we don't want to start with carbon monoxide. We want to end with carbon monoxide. So what we're going to do is I'm going to reverse this guy and say CO2 in its gaseous form goes to 1/2 O2 in gaseous form plus CO, carbon monoxide in gaseous form. And my delta H is now going to be the reverse of what it was originally. So it's just going to be positive 283 kilojoules for every mole of reaction. Now this is actually, it seems like a pretty simple one. What I can do is on the left side of the equation, I have carbon dioxide on the right and on the left. And I can cancel those out. Now, here's the interesting point though. I want to start with 1/2 mole of O2, but I have 1 mole of O2 over here. However, because I have O2 in the reactants and the products, I can cross out 1/2 on both sides. So subtract 1/2 O2 on the both sides. It's going to get rid of this guy, and it's going to turn this one into 1/2. Does everyone see what I did there? Okay. So now if I rewrite this reaction, I end up with C elemental carbon plus 1/2 diatomic oxygen, which produces 1 mole of carbon monoxide. Now in this case, if I look at the delta H, the enthalpy values for both of those half reactions, and I add them together, I'm going to get negative 393.5 plus 283, which is going to end up with a value of exactly 110.5 kilojoules per mole of reaction. And now, just to make sure, is this equation the same equation that we wanted to start with? Yes, it is. Check, check. So we know that the answer to this question is 110.5 kilojoules per mole of reaction. And that is your answer.